So let's look at how we deal with probability trees. So they're called trees because we have these kind of branch-like structures going on here. Okay, and they're just a way that helps us to figure out what's happening and what the probabilities are when more than one thing is happening. So in this case, James goes to an arcade and he has one go on the teddy grabber and then he has a go on the penny drop. And we want to see and find out what the probabilities are of, for example, him winning both of them or not winning both of them, that sort of thing. So we're trying to do probabilities for two separate events. So the first event is in the first section here and the second event is here. Now, even if in real life both of the events would happen at the same time, so for example, if this was about rolling two dice and adding the scores together and so on, even though literally you would roll both dice at the same time, we would pretend that you do it in separate. So we put the first dice here and the second dice there and so on. So they've told us that the probability that he wins on the teddy grabber is 0.2. So the probability that he will lose is 1 minus that, because those probabilities have to add up to 1, because he either wins or he loses, and the 100%, if you like, of probability is 1. So 1 minus 0.2 gives us 0.8. Okay. Now, on the penny drop, it says that the probability he wins there is 0.3. So the probability that he loses is 1 minus 0.3, which is 0.7. And then this is the same down here as well. So we have to have two branches here, because this first set here on the penny drop is for when we win on the teddy grabber, and this second one is for when we lose on the teddy grabber. I'm just going to put W and L, W, L, W, L, just so it's a bit more clear for you to see there. So in this particular question, they're asking us to work out the probability that James wins on the teddy grabber and also wins on the penny drop. So we're going to need to follow this pathway along here. So I'm just going to tick that so you can see. So there are 4 possible routes or paths, but the only one we're interested in is this one here. So the information we need is what happens, what is the probability of both of these things happening. So the probability that he wins on the teddy grabber and on the penny drop, and I'm stressing that "and" for a reason. So when we're dealing with probability, that word "and" equates to multiplying the probabilities together. Another way to remember this is that you multiply along the branches. So the probability that he wins both, in this case, is going to be 0.2 times 0.3. So you might have to brush up on your decimals. Okay, so it's not 0.6, but 0.06, just for the doubters among you. So 0.2 times 0.3 gives us 0.06. Okay, so you will need to know your decimals and your fractions to do probabilities. Okay, so let's look at another example. Okay, this is a socks in the drawer example. So it tells us up here that we've got 5 socks that are black and 3 that are white, so that's 8 altogether. Natalie takes a sock at random, writes down its colour and puts it back into the drawer. Now that's an important statement. I'll talk about that in a minute. So again, this is a situation where actually you probably would take both socks out at the same time in normal, but we have to pretend as if we take one sock and then the second. So if we think about it, the probability that we get a black sock is going to be 5 out of 8 because there are 5 in there and 8 altogether. So we're dealing with fractions this time. So the probability of a black sock is 5/8. And then the probability of a white sock, similarly, is going to be 3/8. Now, when we move on to the second sock, the important phrase is that she's put back the first sock that she pulled out. So that means that there are still 8 socks in the drawer, there are still 5 black, and there's still 3 white. So the probabilities haven't changed. So the probability of having a black is still 5/8, and the probability of a white is 3/8, and that's the same down here as well. So what do they want to know this time? They asked us to work out the probability that the 2 socks are the same colour, which is obviously ideal, generally speaking. So let's look. How can we get 2 socks the same colour? Well, we can either have 2 that are black, or we can have 2 that are white. So first of all, we've got to work out the probability of getting 2 that are black. So remember, black and black, that means we're timesing. So we've got 5/8 times 5/8, which is 25/64. Do the same for the white. So the white, we've got 3/8 times 3/8, and that gives us 9/64. So now we know individually the probability of getting 2 black and the probability of getting 2 white, but we want to know what the probability is of getting either 2 black or 2 white. So that's where another key word's coming in. So that or word relates to adding. So it's either 2 black or it's 2 white. So what we've now got to do is add together the 2 probabilities that we worked out. So 25 plus 9 is going to give us 34. Now don't simplify until you get to this end point. If you do it earlier, we couldn't really do it anyway here, but if we do it earlier, we won't have the same thing on the bottom and they won't add together nicely. But here they're both even, so we're going to divide by 2. So that's 17/32. That's as simple as it can get there. Okay, so let's look at another example. This time this is green and blue counters in a container. All right, and we're told that the probability of getting a green is 7 out of 8. So the probability of getting a blue will be 1 out of 8 because 1/8 plus 7/8 makes a whole 1. So let's fill that in on the rest of this diagram. Let me check, because I need to know if he puts the counters back actually, which I'm fairly certain he does, but let me read it. And yes, it says that he replaces the first counter before he takes the second, so there are still the same number of counters in when we do the second one, so the probabilities don't change. So let's just fill all of that in. Okay, that's our first 2 marks, by the way. So now it says work out the probability that Kevin picks counters that are different colours. Okay, so what route would that be? So if he picks a green, then he'd have to pick a blue. So that's the first one. And if he picks a blue first time, then we need him to pick a green the second time. So remember, along the branches we multiply. So for the first one, it's 7/8 times 1/8, which is going to give us 7/64. And then for this one, we've got 1/8 times 7/8, which is also going to give us 7/64. And then remember, if we want the probability of either this path or this path, we need to add the probabilities together. So 7 over 64 plus 7 over 64 equals 14 over 64, and then simplify by dividing by 2 to get 7 over 32. Okay. Oops, can't pick that up. Let's look at another one. So this is about throwing darts, trying to get the bullseye. So it's whether or not she hits the bullseye on her first throw or a second throw. So the probability on her first throw of her hitting the bullseye is 1/4. So the probability that she misses on her first throw is going to be 3/4. Now on her second throw here, it's telling us that her probability of hitting it is now only 1/3. So that means that the probability that she will miss the second time round will be 2/3. Okay, and these will be the same for both. It's always this. Well, no, that's not quite true. We're going to see something where that's not true in a minute. Okay, so in this case, that's the same. So what do they want us to work out? They want us to work out the probability that she hits the bullseye at least once. Now watch out for that, at least once. So if she hits it and then hits it the second time, that counts in at least once, because twice is more than once. If she hits it here but misses the second time, then that's once. If she misses and then hits, that's once. So actually the only one that isn't included here is this one here. Okay, so when you're in this situation, you can do a little bit of a cheat, because you, instead of working out all of those 3 paths, what we can do is say that the answer is going to be 1 minus the probability of this path here, because these probabilities at the end here all need to add up to 1, just like they do here. So the easy way to do this is to do 1 minus the probability of this. So what would we get here? We'd get 3/4 times 2/3, and that gives us 6 over 12. And you can simplify that one this time. So that 6 over 12, hopefully you can see, is the same as 1/2. Okay, so 1 minus 1/2 is 1/2. So the probability that she hits the bullseye at least once is 1/2. So just remember that shortcut. Just saves you multiplying all these other branches and adding them together. Final example. So we're finally going to look at what happens when things aren't put back. So here we've got marbles in a bag. There are 6 red and 4 white. That's what we've got to start with. So George takes out a marble at random and records his colour. So that's the first time round. So we've got 10 altogether. So the probability of a red is going to be 6 out of 10, and the probability of a white is going to be 4 out of 10. Now the next line says without replacement, so he doesn't put the counter back in, he takes another one out at random. So if we've taken a red one out already, there's only going to be 9 counters left, so that's the bottom now, and there's only going to be 5 that are red. If we think about the white, there's only 9 in there because 1 red one was taken out, but there still will be 4 white ones left. So that's the probability there. So then let's do these as well. So if we take a white one out the first time, then the probability of getting a red one the next time, there's only 9 in there, but there's still all the 6 red ones left. So that's 6 over 9. Probability of getting another white is now going to be 3 over 9 because we've removed a white one before. So it asks us to find the probability that the two marbles are the same colour. So that means we want the path that is red, red or white, white. So red, red is 6 over 10 times 5 over 9. So that's 30 over 90. And this one is 4 over 10 times 3 over 9. So that gives us 12 over 90. So now we need to add those together. So 30 over 90 plus 12 over 90 gives us 42 over 90. So let's see if we can simplify these so we can halve them. So that's 21 over 45. Now these numbers divide by 3, so we can go smaller. So 3 sevens are 21 and 3 15s are 45. So our final answer is 7 over 15. So just be aware and look out for whether things get put back or not, because if they don't get put back, it changes the probabilities in the second go, so to speak.